Howdy, my name is Mark Ramirez. I am a recent graduate from the University of Texas at San Antonio. Today we're going to be testing the gaseous methane and gaseous oxygen rocket engine that I built and designed and manufactured for my independent study class for my last semester here at UTSA. In the fall of 2020, I approached Dr. Pineda about doing some kind of independent study with him with, related to aerospace engineering. He quickly suggested that I design the rocket engine that's going to go on our test stand. I was able to leverage my previous manufacturing experience and design an engine that's going to be used for plenty of future UTSA students. So part of the purpose of this project was to give me a lot of experience with gaseous rocket engines. I hope to work in the aerospace industry someday, working on rocket engines on large full-scale flight vehicles, and this is a great stepping stone for me to do that.
The purpose of the test article being manufacturable on campus by a student and in the time frame of a semester was to get to the testing phase as quickly as we could. We would get the experience of the propulsion testing, and the students can get the experience of like, what do we need to go out there, like what's the packing list, developing the procedures, because it's all going to be different than it was, when we were testing that solid motor. There's a lot more steps. There's a lot more things that can go wrong. And now that we've gone past the testing phase, like we had a successful test, it's not just on pen and paper anymore. Like students are now asking questions. They're like, oh, what if we changed, this valve to a different type of valve? What if we changed the injector? How would the system perform differently? Could it be better? Could we get better performance? So these were questions that weren't being asked before we tested. And now we're there. And we've kicked off the spark that's going to be motivating students to dig more deeply at some of the questions and do a more thorough analysis before they build it. So now we're going from design, build, test, and we're closing the loop again. So we're going to go back, and then we're going to iterate, and then we're going to get better. The second important part was having a workhorse chamber that we can modify or use however we want in future iterations. But we've got a lot of work to do before we get there, as you can see. Like the first test was just like a big flamethrower, and then it propagated back into the chamber, which was like, did we predict that was what was going to happen? No. But when we were out there, it was like, oh, this is how it's behaving. Now let's change our timing procedure to account for that. My vision for this is, now that the infrastructure has been built and now that we've got a hot fire under our belts, we've got some footage, we've got some preliminary data, that student groups will kind of take the initiative to utilize the infrastructure that we've built to test new designs for their competitions. And that's going to be, I think, kind of the lead. It's going to go into two paths. This is going to go into this path where the students kind of want to use it for propulsion testing for their intercollegiate competitions. So like if ARC wants to build a hybrid motor, that's something that they can test very easily now. They can buy an existing motor, they can test it with all the infrastructure that we have already built. The other avenue is the research avenue, where we can start scaling down the test articles to and leveraging our additive manufacturing capability at UTSA to have something that could hopefully be fired in the laboratory, something that's very small impulse, something controllable, something that we can reliably put laser diagnostics on. So those are the two paths that I see, and they're not mutually exclusive. We can pursue both. The infrastructure we've already made the investment.